Hello everyone, today we're going to look at radians and degrees. So the first question is, what is a radian? A radian is the amount of angle needed so that the sector cut out of the circle is equal to the radius. So we have our picture here, the radius is r, and if the arc length of the sector is also r, then that angle is 1 radian, which is why radian sounds a lot like radius. We know that a full circle is 360 degrees, but what is a full circle in radians? If we go back to the fact that the circumference is 2 pi r, and a radian is r around the circle, there must be 2 pi of them. So there are 2 pi radian in a full circle. We're going to use the half circle equivalence, so 180 degrees equals 2 pi rad. So RAD is sometimes used for radians, but radian doesn't have a unit, unlike degrees where the unit is degrees. So if you see a number and you know it's an angle, but there's no degree symbol, then it's in radians, which is why it's really, really important on your work and on the tests and everything that if you're talking about degrees, you have the degree symbol, because otherwise you're saying it's radians. So what we're going to do with that equation is we're going to set up a proportion. So our proportion is d over 180 degrees equals r over pi. So capital D is the angle in degrees, and capital R is the angle in radians. So if I want to go back and forth from one to the other, I plug in the one I know, and I solve for the one I'm looking for. Now notice both sides of the equation are pretty easy. If I want to solve for D, I'm going to multiply both sides by 180 degrees. If I want to solve for r, I'm going to multiply both sides by pi. So let's do some examples. Convert the following radian angles into degree measure. Sometimes our radians are going to have pi in them, and if they do, then converting it to degrees is going to be fairly nice. So we plug in our r because we know the radian, and we're looking for d. Now notice I have 2 pi over 3 divided by pi. My pi's cancel really nicely. And I'm left with d over 180 equals 2/3. Again, I want to solve for d, so I multiply both sides by 180. So d is 2/3 times 180, which is a very nice 120. And then again, don't forget the degree symbol at the end. So 2 pi over 3 is 120 degrees. Sometimes our radians don't have the pi in them, so 1.89. Again, I'll plug it into the r spot in my equation, multiply both sides by 180, and then I'll plug this into my calculator, and rounded to 2 decimals, I get 108.29 degrees. Pi over 5. So again, I'll plug it in for r. My pi's cancel, and I'm left with d over 180 equals 1 over 5. So don't forget that 5 in the numerator is really in the denominator. So pi over 5 over pi isn't 5, but 1 over 5. Multiply both sides by 180, and I get a really lovely 36 degrees. And then the last one for this section, 4.5. So again, notice there's no degree symbol, so it must be radians. Plug it in for r, multiply both sides by 180, plug that into my calculator, and I get 257.83 degrees when rounded to 2 decimals. Make sure that when you're plugging this into your calculator, you're using the pi button and not just rounding to 3.14. So you never want to round in the middle when you can help it. So use the pi button. All calculators should have one. Okay, so let's go backwards. Convert the following degree angles into radian measure. 45 degrees. I'm going to plug that in for D. Notice the degrees cancel. 45 degrees over 180 degrees. The degrees cancel. Again, I'll multiply both sides by pi this time since I'm looking for r. And then there are 2 different types of answers you can get. The first one is in terms of pi. So all I'm doing is simplifying this fraction. So 45 over 180 is 1 over 4. And 1 over 4 times pi is pi over 4. Okay, so depending on how the question is worded, if you want to leave it in terms of pi, then just simplify the fraction and leave pi there. Otherwise, it will ask you to round to so many digits. So if I want to round to the nearest hundredth, I plug pi divided by 4 into my calculator, and I'll get 0.79. So let's try 265 degrees. Again, that goes in for D. Multiply by pi. And then again, I'm going to take this fraction and simplify it. And I get 53 over 36. So whether you want to put the pi in the numerator or just next to it, right, this is the same thing as 53 over 36 with pi out front. It doesn't matter where you put the pi. But if it asks for in terms of pi, it has to be one of those two. But let's say I wanted to round to the nearest hundredth. So again, I just shove it into my calculator, and I get 4.63. How about 460 degrees? Notice this is more than a full circle. So I know right away that my answer better be more than 2 pi. It's got to be more than one full circle. So again, I plug it in for D, multiply by pi, simplify my fraction. So 460 over 180, I can get rid of a 20 on top and bottom, and end up with 23 pi over 9, which is more than 2 pi. Plug it into my calculator, and I should get 8.03. And then for the last one, 24.6 degrees. So again, I plug it in for D, multiply both sides by pi, simplify my fraction. So notice I have a decimal and a fraction. You really don't want to put those two together. So to get rid of it, I want to get rid of that decimal on top. That means I'm going to move the decimal over 1, but whenever I do that to 1/2 of my fraction, I have to do it to my other. So I would start off with 246 over 1800 and then simplify from there. Okay, so I believe you can take a 6 out of both of those, and you'll be left with the 41 over 300. Okay. Also, don't forget your calculator will simplify fractions for you. So ignore the pi, put 24.6 over 180 into your calculator. You'll come up with a decimal, but then you should have a button that will convert decimals to fractions, and that will give you the 41 over 300. And then lastly, rounding it to the nearest hundredth, I put that whole thing into the calculator, and I should get 0.43. Okay. So try out the homework and let me know if you have any questions. Thanks.